All right, let's talk me through it.
Okay, so I think this is fairly straightforward. So when you ask the question, does when you suggest that a POMDPs generalize MDPs, what you're really saying is that if I have a true MDP, the POMDP can represent it basically without any painful extra effort. And so that means there has to be a case where there's really a direct and simple connection between the parameters of the POMDP and the parameters of the MDP. And you've already taken us a pretty far way there by pointing out the states of the states, the actions, the transitions, the transitions, and the rewards of the rewards. So what would the observables be? Well, if there's no uncertainty, there's no, confusion about what the underlying state is, then one way to capture that would be simply to point out that Z is S. There's a one-to-one correspondence from every state to every observable.
Okay, yeah, that's what I was looking for. I would say it a slightly different way, which is the notion that the vocabulary of things you can see, we might as well just reuse the vocabulary of the states because we're going to get to see them directly.
Right. So there's state 1, 2, 3, 4, 5, and 6. There's observables 1, 2, 3, 4, 5, and 6, and they match up in the obvious way.
Sure.
In other words, you can observe the states.
You can observe the states. Well, so far, all we've said is that the set of things you can observe is equal to the set of states. Now, we need to define the observation function to say that what we're really observing is the state.
Well, wait. So that's to go. So those two things together will sort of give us what we want. So here's what I'm going to say. For any particular state, there is a particular Z, and no other Z matches that state, and no other state goes with any other Z. So I'm going to say that the probability of you seeing Z when you're in state S is 1 if S equals Z.
Which we could just shorten as 1 if and only if S equals Z.
Right, and that works because probabilities have to add up to 1.
Yeah, but there's additional constraints on this observation function that make it an observation function, or make it a probability distribution.
Yeah, so we could write that out as like, for all I, Z of I equals S of I or something.
Excellent. All right, so now that we get that idea, let's try to use it a little bit.
Okay, well, wait, is it, I think it's obvious, but is it obvious from here that MDPs do not generalize POMDPs?
Well, we would need to find some way of figuring out how to smoosh the observation function and the set of observables into the MDP itself. It doesn't seem so obvious that you can do that. Ultimately, we are going to do something a lot like that by expanding the state space significantly of the MDP. But I don't know. I mean, do you have something in particular in mind for that?
Actually, probably just that. I was just thinking that I could, if I could tag all the states with the observables and update the transition function accordingly, I could probably do it. But I guess it's not the same thing as saying an MDP generalizes a POMDP.
Agreed. Yeah, you can try to make an MDP out of the observations themselves, but it need not be Markov, right? It could be that you can see the same observation twice in a row when in fact you've actually changed the state and you changed the distribution over what futures are going to be like from there. So I guess that's a slightly subtle point, but the fact of the matter is it doesn't really go the other way unless we expand out our notion of state.
Okay, cool.